Yeah, so we are so used to saying that heat is transferred, but we have to understand how exactly does that happen. And we usually say that heat is transferred when particles have kinetic energy, and the more kinetic energy they have, the more hot that thing will feel. So if you touch a thing with a high kinetic energy of the particles, it will feel hot. But how do you know that the other thing has particles at higher kinetic energy? How does, so for example, if there's a cup of hot milk, if I touch that cup, how can I sense that the milk inside that cup is hot? Like, what exactly is happening between the milk, the cup, and my hand when I touch it? So for that sense, we have to understand how exactly heat is transferred. So heat is transferred when particles move. So if one particle is moving, it hits the other one, that also moves. That other one also hits the next one, and that also moves, and so on. So the transfer happens. But the thing is, anybody who has played dominoes, they know that if you push one with a high force, the last one will not be having the same force. The force keeps on reducing. क्यों? क्योंकि बीच में that force is being used up by other ones. There is friction and all that you're countering. Just like that, when one particle moves and the other one also moves after hitting it, some energy is obviously going to not being transferred. So सारी की सारी transfer नहीं होती, कुछ ना कुछ वहां पे रह जाती. So how do we quantify that? So the first formula of how heat is transferred or how heat is stored, this is it. MC delta T. And I will get to this formula in a bit, कि कैसे ये formula आता है और क्या है. But first try to understand in this way. So there's this reservoir, and it has a lot of water in it. And I want water in this small cup. This one is empty at the moment, and I want water to be poured in there. Now here's the structure. I cannot, for some reason, transfer directly from here to here. I make a pipe like that, but the problem with this pipe is that there's a bigger opening here, and then the water will transfer. How will I get water in here? First, water has to fill this one, and here the water will fall down, and this one needs to be filled. And once this is completely filled up to this point, then water will fill this up. देखो, इतना ज़्यादा पानी मैंने यहाँ से निकाल लिया. This level is going to go down. But अभी तक this small cup has not received a drop of water, right? So this has to completely fill this pipe, and only then, once it's all filled and this opening is filled, only then will I get some drops of water in here, right? Make sense? So I say that imagine if this one did not have enough water to fill this completely. Yeah, sorry about that. So imagine you did not have enough water in this side to fill this completely. Then there won't be any water coming in here. It is very important for this water to be good enough so that it is transferred and completely fills this medium in the middle, and only then will we get some water on this side, right? So what I really need to know over here is that I cannot use a really big pipe. I can't use a pipe that is so big कि वो सारे का सारा उसकी volume को खुद ही खा जाए. If I want to transfer from one to another, a narrow pipe is a much better choice. Again, I have to consider कि मुझे कितनी जल्दी यहाँ पे पानी चाहिए, right? Do you understand this idea? So basically what I'm trying to gauge over here is that I want the capacity of this medium, the volume of this medium to be really small, so that my water from this big container, the reservoir, is transferred to this container at a really fast pace. If the capacity of this pipe is high, this container will not get much water because ये रास्ते में उसको खा जाएगा, right? And that is how we can think of heat. Heat is energy, right? So think of this as that I was giving you the example of milk in a cup. So that's my cup and there's milk in there. So this cup has some walls, obviously, and they will have to get hot before somebody touching on this side can sense how hot this thing is. So what happens is that this milk has energy in it, and that heat energy is first transferred to the walls of the container, and then it is transferred to the person who is touching it or sensing how hot that cup is. Now imagine if this was something that has a low capacity. I'm not talking about the capacity of the cup. I'm talking about the capacity to take energy. If these walls had a low capacity, what will that mean? That the person touching it will feel the heat right away because they're not going to contain much energy khud se. The walls will not store any energy. They will transfer it right away. But if the walls of the cup had high capacity to store energy in them, then what would mean is that first heat needs to warm these walls up, and after that will the person touching it feel the heat that is emanating from this milk inside, right? So that's the idea here, that whenever you want to sense or you want to feel heat coming out of something, every medium in there must get warm, must store some energy, and then transfer it forward. So that means things that have low capacity will make really good conductors. Why? Because they will not store energy in them. Because capacity is what? Capacity is what they need to fill in before they transfer it forward. So every container, every material that you get to sense heat in something else basically takes the heat, stores it inside, and then transfer. जब तक वो अपने में store पूरे तरह से नहीं कर लेता, तब तक वो आगे transfer नहीं कर सकता. So things with high capacity will be a bad conductor. Okay, I don't know why I wrote container, they're conductor. So what does that mean? Heat capacity now would mean the amount of energy anything has to store inside before it transfers. Heat capacity is the energy that they store inside them before they transfer. Now the thing is, every material, every container, every substance has its different capacity, and it all depends on how many particles there are, how they're combined together. All of those things come into play over there. All right. So we have to consider what makes anything a good conductor. Of course, it's about having low capacity. But why does that happen? It has to do with how particles are packed together. If the particles are really close to each other, if you hit one side, it will suddenly transfer that to the other side if they're really close together. But if the particles are far away, so if the particles are like really, really close together, imagine a game of dominoes. If you hit this one, this transfers it right away to this side, right? If you have dominoes stacked really close to each other, then a small nudge over here will topple over the last one. But if you have dominoes that are really far apart, then what will need to happen is you hit this thing and it will first topple, then this one, then this one. It will take a little bit longer for the last one to fall, right? Just like that, when particles are arranged like this, if you heat this one, if you push this one, if you give it more energy, it will transfer to this one, which will transfer to the next one, to next one, to next one. And that is how energy is transferred. But if the particles are far away, then this must hit and move to this position, then hit this one, then move to this position, hit this one, move to this position, then hit this one. What that means is it will need energy that not only pushes it to this distance, but also pushes the other one to this distance, to the other one to this distance, which means this will have a high capacity. It will need more energy itself so that it can transfer to the last one. But this one doesn't need more energy. The particles are really close together and they're moving or vibrating, and they will quickly transfer the energy to the next side. So it has low capacity. So that is just one reason why metals, for example, have low capacity, because particles are so close together and the electrons are moving so rapidly that if you heat one side, which means you heat just one side, you give energy to the one side, and the particles are close together, they will quickly transfer it to the other side because they don't store much energy in themselves. They don't need it. But wood, for example, if you heat one side, it will take a while for that energy to transmit or transfer to the other side, because particles have to move. वो move कर ही नहीं रहे इतने ज़्यादा, and then they have to hit. So what are the chances कि वो move करेगा, फिर hit करेगा, फिर अगले वाला move करेगा, फिर hit करेगा. So slowly and gradually, the energy is used up in all that process. There's a lot of energy wasted within the wood. So wood is a bad conductor. Metal is a good conductor, usually. Okay, and you understand the reason, right? So what is heat capacity? Heat capacity is the energy anything has to store in it before it transfers it forward. So for a good conductor, you need low capacity. For a bad conductor, you will have high capacity. So for example, if I'm going to have a hot cup of tea, hot cup of tea or hot cup of milk, then I would want that cup to be made of something that has a very high capacity. Why? Because when the warm milk or tea or whatever heats the cup up, I don't want the cup to transfer that to the outside. I want the cup to store that energy in it. I don't want it to transfer it to me when I'm holding it. And that means कि जितनी देर में वो कप गर्म होगा और मेरे हाथ तक वो गर्मी पहुंचेगी, तब तक मैं वो चाय पी चुका हूंगा. Okay, but if I want to cook something, if I want to, I don't know, रोटी बनानी है मुझे, ठीक है, so and I wanted to put, वो क्या चीज होती है, तवा, हाँ, तो तवे पे मैंने रोटी बनानी है, तो I want that tawa to be made of a very good conductor, because I don't want कि जो नीचे से शोला आ रहा है, जो हीट आ रही है चूल्हे से, वो उस रोटी तक देर से पहुंचे. I don't want that tawa to be warm, right? I want the tawa to transfer the heat from the flame to the roti on it. I don't want it to store a lot of energy in it, right? And that is why we do all sorts of things, and we design things in a way that fulfills their operation, their function. So usko hum padhenge when we study radiation and conduction and all those methods of transferring energy, कि हम कैसे उनको use करते हैं whenever we design stuff. So you might see that things that we want to transfer energy with, we make them in darker colors. So तवा काला होता है. अब काला होने की बहुत सारी reason है, but main reason एक ये है कि वो काला अच्छा है, because it transfers energy better. It doesn't store it inside, it radiates it forward. And we will study about it, what factors make things do that. So heat capacity is all about कि उसने खुद कितनी energy store करनी है before it transfers. ये concept clear है सबको? The concept needs to be clear before we move on to the calculation part. So anybody who doesn't understand, yeah.
Sir, वो class की timings आज 4:30 तक होंगी.
Do you have a class at 4? I think you have a class at 4, right?
नहीं सर, मैं इसलिए पूछा क्योंकि उस क्लास की भी टाइमिंग चेंज कर दी है, वो 4:50 तक एंड होगी, 3:30 शुरू होना था उसमें.
ठीक है. So if you have to go, you can leave in the middle. That's fine. I'll share the recording with you. अगर कोई क्वेश्चन हुआ मुझे बाद में पूछ लेना, ठीक है?
Okay sir, thank you.
Yeah. So does everybody understand what heat capacity is and when it needs to be low and when it needs to be high? There might be, if you go to chat, वहाँ पे buttons होते हैं. उन buttons को आप click कर सकते हैं कि अच्छा ये आ गया समझ या नहीं आया समझ. Now tell me, if you want to store a hot container, a hot substance in something, would you want to make that thing out of a substance with low capacity or high capacity? मैंने container बनाना है जिसमें मैंने गर्म चीजें रखनी है, store करनी है. High capacity. Good, that is correct. Why? You can unmute your answer.
Be a bad conductor, store heat rather than radiate.
Again, why do I need it to be a bad conductor and why do I need it to be a high capacity thing? So that it can store heat and not transfer it. Yes, exactly. So I wanted to store more and transfer less. So very good. Okay, so if I want something to actually so for example, I want to transmit the heat from the sunlight to the photovoltaic cell. So when I design a photovoltaic cell or solar cell, do I want it to have a high capacity or a low capacity? Okay, so you want it to have low capacity. Kyun? Yes. So for faster transfer of energy, I need it to be a low capacity thing so that it doesn't withhold that energy. It transfers it to wherever I want it to transfer it. Excellent. तो इसका मतलब है आप लोगों को समझ आ गया। अब हम चलते हैं कि हाउ डू यू कैलकुलेट दिस एंड हाउ वी कैन आइडेंटिफाई कि अच्छा हीट कैपेसिटी कितनी है। सो हियर्स द थिंग, what factors affect how much energy is stored in anything depends on how heavy that thing is, basically how many particles it has. ठीक है, जितने ज्यादा particles होंगे obviously that heat is going to be distributed in those things. Secondly, how hot do you want it to be? That is also a factor. So the factors that are over here is आपके पास कितनी energy है, आपके पास कितना mass है जिसमें आपने उसको ट्रांसफर करना है. So the energy will be divided into all of that mass, right? So it will be divided by that mass. Also, आपने उस हीट को कितने डिग्री सेल्सियस में कन्वर्ट करना है, कितना टेम्परेचर का डिफरेंस लाना है, so that heat whatever amount you give will be distributed. अच्छा, ये इतने डिग्री का चेंज लाने के लिए आएगी. So not only for that mass but also for the change in temperature that you want, and that will be my heat capacity. And this thing, whenever you do it for a standard value or 1 kg mass or 1 degree Celsius, we call it specific. So the word specific simply means that what is it happening for 1 kg and for 1 degree. क्यों? क्योंकि ये जो चीजें हम divide कर रहे हैं ना, we want them to be unit. We want it to be unit mass and unit change in temperature. That means अगर मैं specific heat capacity को define करूं, so this is energy, right? So it is the energy per unit mass per unit degree Celsius. So इसका मतलब क्या हुआ? It is the energy I need. So specific heat capacity of anything would be the energy I need for 1 kg of that mass to heat up by 1 degree Celsius. एक चीज का अगर मुझे change समझ आ जाए, तो if I have 5 kg of that thing, I'll simply multiply it by 5. And if I want to do it for 5 degrees Celsius and multiply that by 5. तो इसका मतलब हुआ कि अगर मैं आपको कह देता हूँ कि अच्छा ये एक मटेरियल है, if I take 1 kg of it and I raise it by 1 degree Celsius, I need 200 joules of energy. Okay, so I have that. So if I have 7 kgs and I want to heat it by 10 degrees Celsius, how much I need? So I'll be like, okay, 1 degree Celsius के लिए मुझे 200 चाहिए, 10 degree Celsius के लिए x चाहिए, cross multiply, I'll get x is 2000 joules. And this is one thing that I'm assuming over here is कि सारा का सारा 1 kg. So इसका मतलब है अगर मैं 1 joules चाहिए, मेरे पास 7 kg है, so 1 kg के लिए 2000 joules चाहिए, तो 7 kgs के लिए x चाहिए होगा, cross multiply and you'll get x equals to 14,000 joules. So I can write 14 kj. kj means kilojoules. So मुझे पता चल गया. So अगर मुझे specific heat capacity किसी भी चीज की पता है, so that is my unit value. अब मैं उसको मल्टीप्लाई कर सकता हूँ, अच्छा 10 kg के लिए इतना चाहिए, 0.2 kg के लिए कितना चाहिए, whatever amount I have or whatever change in temperature I want, I'll just multiply it with it. So that gives me, ये मुझे क्या मिली है, ये है मेरी energy. So that tells me that if I know the specific heat capacity, I can just multiply it by mass and I multiply it with how much energy change I want, temperature change I want, and I will get the total energy required. So heat को usually Q कहते हैं. And there you go. I found my first formula here, जो हम शुरू से जिससे बात करते आ रहे हैं. So this formula is nothing but explaining the concept in a mathematical way. अच्छा, अगर मुझे सिर्फ ये पता करना है कि 1 डिग्री सेल्सियस के लिए चेंज चाहिए मुझे, I just want it for 1 degree Celsius, so I can just put 1 here and that will give me the energy for 1 degree Celsius. और इसको हम कहते हैं कैपिटल C, कि जिसको हम आम जुबान में हीट कैपेसिटी कहते हैं. हीट कैपेसिटी ऑफ एनीथिंग इज सिंपली द energy you need when the change is 1 degree Celsius. So Q is equal to mc delta theta. This Q has a special name, इसको हम mc बोलते हैं या c बोल देते हैं. So जब भी कैपिटल का लफ्ज आएगा, that is for any body made of that. But when you have a small letter, then that means for 1 kg and 1 degree Celsius for that thing. So any body for 1 degree Celsius is capital C, and any body but 1 kg and 1 degree Celsius is small letter. So हम बस specify करें, अगर 1 degree Celsius का change चाहिए, mass कुछ भी हो सकता है, तो वो heat capacity है. और अगर मुझे 1 degree Celsius के साथ 1 kg चाहिए, तो that is small letter, and that is my Q is equal to mc times 1, which I call C. So इसका मतलब हुआ कि जब भी कोई चीज, number one, whenever you heat something or you wanted to transfer energy, it must heat itself before it transfers it. The energy it needs to store so that it can transfer is heat capacity. If you want to do it for 1 degree Celsius, then that is called heat capacity. And if you want to do it for 1 degree Celsius, but also for 1 kg, that is your specific heat capacity. And that is the whole idea कि heat capacity क्या है और कैसे है. अब इसकी example, where do we see it? So for example, I'm sitting in the room and I have a table which is made of wood and I have a laptop which is made of aluminium. So let's suppose the AC is on, and now if I touch the laptop, it might feel colder to the touch compared to the wood, the table, which doesn't feel that cold to the touch. ऐसा क्यों हो रहा है? So it's really simple. First thing you have to consider it, what is the warmer thing? Because heat always goes from the warmer thing to the colder thing. So my body temperature is way more than the room temperature right now, right? Room temperature, let's suppose it's 22 degrees Celsius. My body temperature, if I'm healthy, it'll be 37 degrees Celsius. So now if I touch the laptop, which is supposed to be at 22 degrees Celsius, then it feels much colder to the touch. Kyun? Because I'm the warmer body and laptop is the colder body, and the heat is transferred from me to the laptop. But because the laptop is such a good conductor, and because it's a good conductor, वो बहुत जल्दी transfer faster rate than if I were to touch the table. क्योंकि table is a bad conductor. Table मुझसे heat ले रहा है और आगे नहीं transfer कर रहा, store कर रहा है और slowly कर रहा है. That means मुझे वो इतना warm नहीं feel होगा, क्योंकि जो heat मेरी body में से temperature में table में जा रही है, बहुत slowly जा रही है और वो वहाँ पे store होती जा रही है. बट जब लैपटॉप को मैं टच करता हूं तो वो उसको मिल रही है और साथ में आगे ट्रांसफर होती जा रही है. सो दैट मींस इट्स कॉन्स्टेंटली सकिंग हीट आउट ऑफ माय फिंगर्स, बट द टेबल इजंट डूइंग दैट. दैट इज व्हाई द लैपटॉप विल फील सो मच कोल्डर टू द टच, क्योंकि हीट कॉन्स्टेंटली उसमें से गुजर के आगे चलती जा रही है, बट नॉट फॉर द टेबल. Okay, so that is how we understand how heat is transferred and what difference it makes, even though both things are at the same temperature. वुड की टेबल की और एल्यूमिनियम के लैपटॉप की टेम्परेचर सेम है. इट इज जस्ट हाउ फास्ट और स्लो हीट इज ट्रांसफर्ड दैट इट फील्स कोल्डर और वार्मर. You might experience it if you step on if you barefooted step on a carpet compared to, I don't know, floor. तो आपको feel होता है कि floor is colder and the carpet isn't that much. Why? Because carpet has air trapped in it, bad conductor, वो इतनी जल्दी एनर्जी आगे तो भेजता ही नहीं है. It has a high capacity, वो अंदर स्टोर करना शुरू कर देता है. Or the floor, because it's probably made of marble or tiles or something, वो जल्दी हीट लेता है और उसकी कैपेसिटी comparatively low होती है, doesn't have any air stored in it. Okay, so that is how we know and we can understand about heat capacity and then design stuff using lower high heat capacity depending on कि उसका function क्या है. Okay, and that is the concept.